On the morning of August 27, 1883, a sound was produced that has never been matched in recorded human history. It was heard in Australia, more than 3,000 kilometers away. It was heard on the island of Rodrigues, near Mauritius, nearly 5,000 kilometers from its source. People who heard it thought it was cannon fire, or thunder, or an earthquake. It was none of those things. Tonight, I am here with Rowan Hartsteele.
Good evening, Clara.
The question at the center of this episode is what happens when the Earth itself releases an amount of energy so far beyond anything human civilization can produce that the only honest response is a kind of a speechlessness. Tonight, we turn to the eruption of Krakatoa in 1883, a disaster that was not merely local, not merely regional, but planetary in its consequences and global in the way it was understood. We ask what it means when nature demonstrates, without warning and without apology, that the scale of human civilization is simply not a relevant category.
Krakatoa was a volcanic island in the Sunda Strait, the narrow body of water that separates the islands of Java and Sumatra in what is now Indonesia. Before August of 1883, it was a known feature of the strait, occasionally active but not considered an exceptional danger. Ships passed through the strait regularly. Fishing communities lived on the surrounding coasts. The island was visible from both shores.
We are speaking about the eruption of Krakatoa in 1883 and its consequences for the world.
Consequences that extended from the immediate and catastrophic, more than 36,000 people, whose lives ended in the waves and the darkness of that August morning, to the atmospheric and climatic, strange sunsets visible across Europe and North America for months, to the cultural, as the modern world encountered for the first time a truly global catastrophe, communicated almost in real time through the telegraph networks that now links the continents.
Then let us begin with the geology that made Krakatoa possible.
The Indonesian archipelago sits on one of the most tectonically active regions on Earth. The Sunda Strait lies at the junction of several major tectonic plates, where the Australian plate is subducting beneath the Eurasian plate. Subduction is the process by which one tectonic plate slides beneath another and descends into the mantle. As the descending plate heats and is compressed, it releases water and other volatiles into the overlying mantle, which lowers the melting point of the rock and generates magma. That magma rises through the overlying plate and produces volcanoes at the surface. The string of volcanic islands running through Sumatra and Java, including Krakatoa, is the surface expression of this subduction process. These volcanoes are fed by magma that is rich in dissolved gases and relatively viscous, which means that when the pressure builds, the eruptions tend to be explosive rather than effusive.
So Krakatoa was not an isolated accident. It was the product of a deep and continuous geological process.
Yes, Krakatoa itself had erupted before, most significantly in the 17th century, and the island was known to be part of a volcanic system. But the eruption of 1883 exceeded anything in the region's recorded history. The warning signs began in May of that year, when the volcano began producing explosions, ash columns and pumice falls that were alarming enough to attract attention passing through the strait. Through June and July, the activity continued but did not obviously escalate. Several ships and observers visited the island to record what was happening, and some accounts from this period describe a volcanic landscape of considerable drama, ash-covered vegetation, hot springs, sulfurous fumes, and periodic explosions from multiple vents. But the impression developed understandably that the eruption might be running its course.
So, the months of visible activity before August created a false sense that the event was manageable.
Yes. And this is a pattern that appears repeatedly in volcanic disasters. The extended period of precursor activity allows observers to become habituated to the spectacle, to normalize what is actually a profound instability, building toward a catastrophic release. The communities on the coasts of Java and Sumatra had been watching Krakatoa produce ash and noise for months. There was no clear moment at which the situation shifted from dramatic but manageable to imminently catastrophic. On August 26th, the activity intensified dramatically. A series of large explosions began in the early afternoon, producing ash columns that rose tens of kilometers into the atmosphere, and producing explosions audible at considerable distances. Darkness fell over parts of Java and Sumatra as ash blocked the sunlight. The eruptions continued through the night.
And then came the morning of August 27th.
Yes, between approximately 5:30 in the morning and 10 in the morning local time, 4 explosions of extraordinary violence occurred. The second and third, at approximately 6:44 and 10:02 in the morning, were the largest. The 10:02 explosion is estimated to have been the loudest sound produced on Earth in recorded human history. The shockwave it created circled the globe multiple times, measurable on barometric instruments in weather stations as far away as England. What produced this explosion was a caldera-forming event. As the magma chamber beneath Krakatoa was rapidly emptied by the eruptions, the overlying rock lost its structural support. The northern two-thirds of the island collapsed into the emptied chamber, and the sudden contact of seawater with the superheated magma produced a phreatomagmatic explosion of almost inconceivable violence.
So the island essentially destroyed itself from beneath.
Yes. The collapse and the explosions generated tsunamis of extraordinary height. The largest waves reached heights of more than 30 meters in some locations. They struck the coastlines of Java and Sumatra within minutes of the major eruptions, moving faster than anyone on land could flee. The waves carried ships far inland. They erased entire coastal villages. In some places the wave arrived so quickly that there was no warning at all. The town of Merak on the western tip of Java was entirely overwhelmed. The town of Teluk Betung on the Sumatran coast was struck by a wave that carried a Dutch gunboat, the Bureau, more than 3 kilometers inland and deposited it on a hillside, at an elevation of approximately 10 meters above sea level. The vessel remained there for decades afterward as a monument to what the sea had done.
So the sea, not the volcano, was what took the most lives.
Yes, this is one of the most important and least understood facts about the Krakatoa disaster. The total death toll, estimated at more than 36,000, was overwhelmingly the result of the tsunamis rather than the eruption itself. The pyroclastic flows, the superheated avalanches of gas and volcanic material that moved across the water surface from the collapsing island, accounted for significant casualties in the immediate vicinity of Krakatoa. But the waves reached far greater distances and struck populated coastlines that had no direct view of the eruption. People who were far enough from the island to have survived the initial eruptions, who may have seen the ash column and heard the explosions but felt themselves to be at a safe distance, were struck by walls of water that gave them no time to respond. The invisibility of the mechanism was part of what made it so lethal. The sea showed no sign of what was coming until it arrived.
So the haunting truth of Krakatoa is that it was the water, not the fire, that erased the most lives.
Yes, and beyond the immediate coastlines the effects of the eruption were felt across the entire planet. The explosion injected an enormous quantity of fine ash and sulfur dioxide into the stratosphere, at altitudes well above where weather systems operate, and where the particles could not be washed out by rain. This material was carried around the globe by high-altitude winds. In the months following the eruption, unusual atmospheric optical effects were observed worldwide. Sunsets and sunrises became extraordinarily vivid, with deep red, orange, and purple colors that were remarked upon across Europe, North America, and elsewhere. The painting style known today as the Scream, produced by the Norwegian artist Edvard Munch, is thought to have been influenced by the remarkable skies he observed in the years following the eruption.
So the eruption left its mark not only on the physical world, but on the artistic record of the era.
Yes, the fine aerosols in the stratosphere also reduced the amount of solar radiation reaching the Earth's surface, producing a measurable decrease in global temperatures in the years following the eruption. 1884 is recorded as a year of reduced agricultural yields in parts of the Northern Hemisphere. The eruption was, in modern terminology, a significant instance of volcanic forcing of the climate. But the most historically significant consequence of Krakatoa may have been neither the geological nor the climatic, but the communicative. By 1883, a network of telegraph cables had been laid across the major ocean basins and between most of the world's major cities. News of the eruption and the tsunamis was transmitted from Batavia, the colonial capital of the Dutch East Indies, to Singapore, to Europe, and then to North America within hours of the disaster.
So Krakatoa became a news event at global scale almost immediately.
Yes. Newspapers in London, Paris, New York, and elsewhere were reporting on the disaster within days, and in some cases within hours. The reading public in Europe and North America followed the development of the story as it emerged from survivors' accounts, from scientific reports, and from the observations of ships that had been in the strait at the time. For many people in the industrial world, Krakatoa was the first natural disaster they experienced as a shared global event. The scientific community responded with particular energy. The Royal Society in London organized one of the most comprehensive scientific investigations of a natural disaster that had yet been undertaken. collecting observational data from around the world on the atmospheric effects, the tsunamis and the eruption itself. The resulting report, published in 1888, became a foundational document in the scientific study of volcanoes.
Before we close tonight, let us take a brief pause and welcome Margaret Evernight. Margaret, for those who want to understand the full scope of the Krakatoa disaster, from the geology to the human tragedy to its place in global history, where would you invite them to continue?
Thank you, Clara. In this case, the most direct path is also the most important one. I would suggest beginning with Krakatoa, the day the world exploded by Simon Winchester.
So this is a work that holds the geological, the human, and the historical together in a single narrative.
It does all three with considerable skill. Winchester combines the geology of the eruption, the human tragedy on the coasts of Java and Sumatra, the colonial context of the Dutch East Indies, and the global scientific and cultural consequences into a narrative that is both rigorously researched and genuinely compulsive to read. He's particularly good on the telegraph and the way the disaster was processed by the reading public of the industrial world.
And is this a book accessible to a reader who does not have a background in geology or colonial history?
Very much so. Winchester writes for a general audience, explaining the science clearly without simplifying it dishonestly, and he keeps the human dimension of the disaster present throughout. He also ranges widely, from the tectonic history of the Indonesian archipelago to the role of the explosion in inspiring some of the most vivid art of the late 19th century, and the range makes the book feel as large as its subject.
So reading it gives you not only what happened at Krakatoa, but what it meant for the world that was watching.
Yes, and it leaves you with a vivid sense of why this particular eruption, out of the many that have occurred in recorded history, became the one that changed how the modern world understood both geological power and its own connectivity.
Thank you, Margaret. That is a thoughtful place to pause tonight.
Thank you, Clara. It was a pleasure.
The aftermath of Krakatoa was in some respects as remarkable as the event itself. Where the northern portion of the island had stood, there was now open water. The caldera that the collapse had formed was submerged beneath the Sunda Strait. The remaining southern remnant of the island was heavily altered by the eruption, and continued to experience volcanic activity in the years that followed. Then, in December of 1927, a new volcanic island began to emerge from the sea within the old Krakatoa caldera. It was named Anak Krakatoa, meaning the child of Krakatoa. The new island grew slowly at first, building itself from repeated eruptions over the following decades. By the early 21st century, it had become a significant volcanic structure in its own right.
So the site of one of history's greatest volcanic destructions became the birthplace of a new volcano.
Yes, and this continuation is in many ways the most honest geological lesson of the Krakatoa story. Volcanic systems do not end. The tectonic forces that produced the 1883 eruption are still operating. The subduction of the Australian plate beneath the Eurasian plate continues at approximately the same rate it always has. The magma generation that fed Krakatoa continues to feed its successor. Anak Krakatau demonstrated this emphatically in December of 2018, when a partial collapse of its western flank generated a tsunami that struck the coastlines of Java and Sumatra without warning, having lost their lives several hundred people. The mechanism was almost identical to what had happened in 1883. The geological system had produced another event, smaller in scale, but carrying the same essential signature.
So the lesson of 1883 was not learned permanently. The danger did not diminish with the passing of time.
No, and this is where the Krakatoa story connects to a broader truth about the relationship between human civilization and the geological forces that underlie it. The 1883 eruption was understood at the time as exceptional, as something outside the normal range of experience. But from the perspective of the tectonic system, it was not exceptional at all. It was one event in an ongoing sequence that has been producing eruptions in the Sunda Strait for millions of years. Human civilization, with its cities and its telegraph networks and its scientific institutions, exists on a surface that is geologically active in ways that do not conform to the timescales on which human beings plan their lives. Krakatoa made this visible in the most direct possible way, by producing an event whose effects reached every part of the planet, and whose violence exceeded anything that the industrial world of 1883 had the capacity to respond to or prevent.
So Krakatoa showed the modern world what it was actually built on.
Yes, nature does not recognize the scale of human civilization. It can erase entire landscapes in a single day, without reference to the population living on them. the infrastructure they have built, or the significance they have assigned to their location. This is not a moral statement about the natural world. It is simply a description of the relationship between geological time and human time, between tectonic energy and the energy of human construction. But the other consequence of Krakatoa, the one that its global media coverage made visible, was equally important. The modern world first began to understand itself as globally connected, not only through trade and empire, but through shared catastrophe. The disaster at Krakatoa was not the concern of the Dutch colonial administration alone, or of the populations of Java and Sumatra alone. Within days, it was the concern of readers in London and New York and Berlin, who followed the accounts of survivors and scientists with the same attention they gave to political events in their own countries.
So Krakatoa was not just a geological event. It was a moment in the formation of a global consciousness.
Yes, the telegraph made it possible for a disaster on one side of the world to be known on the other within hours. The scientific networks of the late 19th century made it possible for the physical effects of the eruption, the atmospheric waves, the climatic perturbation, the vivid sunsets, to be understood as manifestations of a single event rather than as unrelated local phenomena. The eruption was the occasion. The connectivity was the context that made it meaningful to people who had never been near the Sunderstrait. In the years that followed, the unusual atmospheric effects continued to be observed and documented. The vivid sunsets of 1883 and 1884 entered the cultural memory of the period, recorded in diaries, letters, paintings, and scientific journals. They were a visible signature of an invisible event, a reminder written in color across the sky that something of enormous consequence had happened.
And then the skies returned to normal, and Krakatoa became history rather than present reality.
Yes, the aerosols settled out of the stratosphere over the course of a few years. The temperatures returned to their previous range, the vivid sunsets faded, and in the Sunderstrait, the sea was quiet above the caldera, where an island had once stood. The geological system continued its patient work below the surface, building the new island that would eventually emerge as Anak Krakatau. What persists from 1883 is not the sound which dissipated into the atmosphere within hours of being produced. It is the understanding, available to anyone who looks carefully at the geological and historical record, that the Earth operates on terms that human civilization did not set and cannot renegotiate. Krakatoa showed that with a clarity that has not been matched in the centuries since then.
Thank you for staying with us tonight, and thank you, Rowan, for guiding us through the geology, the wave, the silence afterward, and the long conversation that Krakatoa began between human civilization and the forces it cannot control.
The loudest sound ever recorded was not made by anything human beings built. It was made by the Earth removing an island from the map in a single morning. That fact has not changed, and the Earth has not finished.
If this conversation stayed with you, you are welcome to like, comment, and subscribe. You will find other episodes here where history, ideas, and power are approached slowly. Until next time, stay with us.